Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain Lab. And today we're looking at a project I worked on, building up an adjustable bipolar power supply. These kind of power supplies are not that common these days. They were very common back in the 70s, 80s, 90s. These are great for powering breadboards for op-amp circuitry, sort of like I have here. But this one is special because it's built around a commonly available LM317 337 adjustable regulator that you can get for $8.50. At least that's what I spent uh, in eBay. And it has decent specs. It has a linear adjustment rate of about 0.01% and load rate regulation of less than a tenth of a percent. Uh, 80 decibels of ripple rejection. Output short circuit protected. Um, Overcurrent, over temperature protected. So you get a lot of really nice things here, and you can adjust this thing from about 3 plus or minus 3 volts up to about plus or minus 40 volts, and it all depends on the transformer and power supply that you're using. You'd use a center tap transformer, and in this case, I built it using a transformer that I had on hand, which was a center tapped 20 volt transformer. So I'm limited. I get 1.5 volts plus or minus to about 15.5 volts. The output current on this thing is capable of going from about 5 milliamps up to about an amp for $8.50. One of the problems on it is that the adjustable voltages are done on board using trim pots, little miniature screwdriver trim pots that would not be a handy thing to utilize. So I decided that I wanted to have a regular front panel voltage adjustment for both negative and positive, and I replaced those 10-turn trim pots with 10-turn um, regular potentiometers for the front panel. And then you need to turn the thing on and off easily. You want to provide power to it. So in order to do that, you need to have a cabinet to mount the thing in, so that you can also mount your on-off switch and have a power indicator. And you'd like to have a place to plug your cord in and out of the back, and you probably like to have it um, fuse protected. So all of these things are challenges that you'd want to meet to make this $8.50 board a lot more usable, user-friendly. And you want to have your outputs. So your outputs, you'd need a set of negative output terminals and a set of positive output terminals. In the case of this unit, I've got the 4 terminals there, and 2 of the terminals are common to each other in that they provide the common line for the reference voltage, whatever it is, common for the negative or common for the positive. I managed to find a cabinet that I had on my shelf that saved me from spending upwards of $50 to $100 at least, I'd say, on a cabinet of similar quality. Used an old HP frequency counter cabinet. The counter was trash, but the cabinet was quite reusable. I needed a front panel, so I bought myself a little plate of aluminum, brushed aluminum, 20 gauge roughly, which was the right gauge to be able to shear with a pair of hand shears easily. So I was able to manufacture a front plate, and I utilized the existing rear plate that was there because It had both the cord inlet, and which I can remove, and it also had a fuse that was available. So both of those things are things I was going to need anyway. So of course I reutilized it. It also has a little wire stand that's retractable, but it gives me a nice tilt, and it's a nice heavy-duty case. Easy. It's just 4 screws on the bottom. Takes the shell apart. Beautiful. Alright, so I've removed the lid of the power supply to show you the latest changes. I purchased a 40 volt center tapped transformer. It's good to 2 amps at its rating. 4 amps max, but and I'm using that to power the supply, which is supposed to be good up to 1.5 amps. However, I can tell you that the heat sinks on this board are poor, very poor. So you've either got to pour a lot of cooling air in here, which I'm going to need to install a fan eventually. I already replaced the regulator once with this new regulator, LM317, and put a little finned heatsink on it, but it's not big enough to do the job. So I'm derating this thing. I'm taking it up to 0.5 amp max, and we're just going to observe what happens to the voltage as I go from about 1/10 of an amp up to about 1/2 an amp. See how much it changes. So let's see. We will turn on the power. Let's see, our light is on the inside there. We're getting 10 volts. I'm going to take this thing up to roughly 1/10 of an amp. I'm going to attempt it. Oops, already jumped by it. There's 0.19, 0.37, 0.39, 0.41, 0.44, 5, 6, 8, 9, 5, 0.51. We didn't budge at all. We're better than 1/10 of a volt up to 1/2 of an amp. And we can go back down again. So our regulation is good. In order to get that, we had to provide an overpowered transformer, so that we made sure that our power supply was not the limiting factor and we weren't dropping voltage back there as we loaded. But giving you a quick look at the inside here. Oh, we've got the power line input. We've got a fuse protection, transformer, power supply, the regulator board, and then we have the controls for the voltage. We can take this voltage up, I think, to 20 volts. There's 15. There's 20, 21, 2, 3, 4, 5. We've got 25 volts on here. Looks like we're leveling out at 25.9. So my guess is that under load I would see this thing drop. In fact, let's go ahead and there's 0.4. We drop down to 24.3. I'm going to guess about 24 point. So I say 24 volts would be the limit that we would want to go. Okay, but that's on the positive side. Be the same for the negative side. I can move my leads. Minimum voltage is 2.09 to the negative. I can go ahead and adjust my current. There's about 0.2, and if I take her up, there's 3, 4, 5, 6, 7, 10, Let's put her at 15 volts. Just it's a good voltage for a lot of op amps. And then as I dial up in current, whoops, we don't want to go more than 0.5 is what I said, right? Looks like we drop about 1/10 of a volt at 0.5 on the negative side. And that's with the original regulator, which is just mounted to the circuit board, no cooling. It's quite warm. I wouldn't recommend this for any heavy currents per se without doing something to cool that unit. Kind of disappointed in that regulator in that sense, but they claimed 1.5 amps, I believe, and I don't feel it warrants that. But there you go. It's a nice bench supply. I'm going to install a small fan in there, maybe put a couple of cooling holes out the sides so we have a cross vent. And maybe I'll figure out some way to heat sink that negative side a little better. But that'll be it, and I'll have a nice little bench supply for working on op amps. Thanks for listening.